In this part, we're going to talk about how probability is used in various fields. In this particular video, we'll focus on where probability is used in finance. For starters, in finance, we are often trying to predict the values and prices of uncertain future events. An easy-to-understand event is option pricing. Before we proceed, we need to understand what an option is and how we determine its price. Okay, so an option is an agreement between two parties for the price of a stock or item at a future point in time. It is called that way because it allows one of the sides to decide whether to go through with the deal at a later date. Since this pact puts one of the parties at a clear disadvantage, the other one must pay them a compensation fee called the premium. Essentially, whoever pays the premium gets to decide if the deal is going to go through when the predetermined point in the future arrives. The pricing aspect of this option represents how much we are willing to pay to receive that pact, or what the highest premium we would agree to is. Okay, let's look at a hypothetical example scenario. You are offered to pay a premium of $100 to an investor for the option to buy 10 stocks of Google at $1,100 apiece 1 week from today. For simplicity, we assume there is a 40% chance the stock is going to increase to $1,200 and a 60% chance it is going to fall to $1,000. You want to know whether this option is worth the $100 valuation. Now, let's break down what happens in each of these scenarios. At the current hypothetical price of $1,100 apiece, 10 Google stocks cost $11,000. If the price falls to $1,000 a week from today, you would be better off buying the 10 stocks at the market price. That results in only paying 10 times $1,000, or $10,000, instead of $11,000. In this case, you would not exercise your right to the option. If instead, the price rises to $1,200, you would want to take advantage of the deal you struck. For each stock, you would be paying $100 less than the market price. So instead of $12,000, it would only cost you $11,000. In this case, you would exercise or call the option. In short, in one case, you go through with the deal and make a profit, and in the other, you don't, but only lose the premium you paid. To help us visualize this example, we are going to use a decision tree. The decision tree describes the different possible payoffs we could get and their associated probabilities of occurring. In our case, there are two possible outcomes. The price either rises or drops. A decrease is associated with a probability of 0.6, and an increase is associated with a probability of 0.4. As we already stated, we do not call the option if the price goes down. Therefore, we only lose the $100 premium we paid initially. When calculating expected payoffs, we write losses as negative numbers, so the value associated with this scenario is minus $100. Now, if the price increases, we are going to spend $11,000 instead of $12,000, so we save $1,000. However, we already paid $100 for the premium, so our actual profit becomes $900. Great job! What we haven't used as information yet are the actual probabilities. With their help, we can find the expected payoff of buying the option. If it is negative, this deal is disadvantageous for you, as you will be losing money. Thus, avoid buying this option unless you love risk and bank on the low probability of making a profit. If the expected value is 0, then this is known as a fair deal. In this case, taking or not taking the deal is equally logical, since the payoffs are just right. On average, you expect to make as much as you paid for it. Now, if the payoff is positive, the rational move would be to follow through with the deal because you expect to make a profit. Let's go back to our example. We have the payoffs for two possible outcomes and their associated probabilities. We use the expected value formula to get 0.6 times negative 100 plus 0.4 times 900. That equals minus 60 plus 360, or $300. Since 300 is greater than 0, this deal is favorable for us, and we should buy the option. Usually, your counterparty that charges the premium is also making their calculations. If they had the same information as you, they would either make the deal unfavorable for you or at least a fair deal. We can assume that on average, institutions writing options are trying to balance the deal out and make it a fair deal. How can they do that? Well, they can charge a higher premium. In fact, if they charged exactly $300 higher for the option, the payoff would decrease by that amount, making it a fair deal. Therefore, we should accept the offer for any premium up to $400. Fantastic! Another way we can compute the price of the option is by calculating the expected payoff if there is no premium. Let's explore this more carefully. If the price falls, just as before, we do not call the option. The expected value for this scenario is 0, since we are not paying a premium or going through with the deal. Alternatively, if the price rises, we would yet again be making $100 on each of the 10 stocks, so $1,000 in total. We already know the probabilities of both events, so we plug them into the expected value formula. We get $0 times 0.6 plus $1,000 times 0.4, or $400. This result matches the price we estimated earlier. Therefore, the highest we are willing to pay for this specific option is $400, so we put a maximum price on it. Now, what if the stock value only increases to $1,125, or the likelihood of a price drop goes to 80%? How would these changes affect our decision to take the deal? For homework, you can answer these questions by finding the expected payoffs of the new options. Generally, investors use probability to determine whether an investing opportunity is worth their money. Knowing how likely or unlikely certain events are helps experienced businessmen make correct calls. Of course, many of the assigned probabilities for these events are ballpark figures. To elaborate, these values are not 100% certain, but rather what we predict they could be. Probability plays a role in finance, but it has an even bigger role in statistics.